Hello everyone, good morning. My name is Ashish Mehta. I'm the marketing manager for NI ASEAN and welcome to the first of a 4-part Embedded Controls and Monitoring webcast series. In this session, I will be talking about a better approach to embedded systems design, where we will be comparing two different scenarios. So the first scenario will be building an embedded systems from scratch or buying off-the-shelf hardware. So whether you should be building or buying is a very important initial question when it comes to embedded systems design. The aim today, though, is to provide you with a structured way to decide what you should be doing based on your specific needs. So before I actually get into the details, I would like to actually take a step back and think about why we are here today as engineers. I believe when you all first decided to do engineering, you had some sort of aim or vision in mind, right? Well, I for sure did. I wanted to make a difference. In fact, I wanted to kind of make a difference in the world and create something really cool. And I'm pretty sure most of you feel somewhat similar. Well, believe it or not, we as engineers have an immense impact on the world. Engineers increase wealth by saving companies and people time and money, and improving the quality of life and safety for all of us. Now here's some examples of engineers in action. Well, over here we have Vestas Technology. Now, their main challenge was they were trying to build a system to measure and control the behavior of a wind turbine blade and to improve the efficiency of wind turbines, which is actually a very cool thing. Now, what they were trying to do was develop an advanced measurement and control system that worked in a limited amount of space and also in a rough environment inside the 3 wind turbine blades. Now, the 3 blades needed to acquire data and communicate with each other at 100 Hz to fine-tune the whole control of each blade. So the data also needed to be stored and displayed on a server on the ground. And lastly, the system had to be scalable and versatile to handle changing specifications as the project progressed. So with the NI platform, they were actually able to build an intelligent measurement and control system that helped further optimize the efficiency of the wind turbines. So this particular application is actually a very cool application that I really like. I remember in NI Week a few years ago, I specifically remember the co-founder of Optimatica, Mike Wertberger. Now he basically described this latest innovative medical device that was based on LabVIEW. And what it was a laser-assisted cataract removal, and it's fully automated. Now this particular procedure uses an NI embedded card to control a femtosecond laser-assisted cataract surgical system, which is absolutely amazing. Now this allowed for a reproducible, non-invasive technique for this particular surgery. So what happened in the end was that this replaced the less predictable and most technically demanding steps of the conventional cataract procedures. So eventually Mike sold his company to Abbott Laboratories for $400 million, which is an absolutely great achievement. So here's an example with Lime Instrumentation. Now, they were trying to build an advanced monitoring system that can survive being mounted directly to an oil well servicing pump, which is a very rugged environment. And what they had to do is you had to perform advanced analysis on sensor data in this harsh environment. So what they did was they actually ended up using NI Compact Reel and NI Single Board Reel hardware along with the NI LabVIEW software, which I'm going to talk about a lot more later on in detail. So they used this hardware and software combination, and they were able to design a pump monitoring system that monitors operating parameters of a reciprocating pump used in well servicing applications. So here's NI platforms used in the harshest of environments. So while many of these applications that we just looked at differ greatly in terms of industrial verticals, they all have similar challenges. And those challenges come in the form of business or development challenges. Now, with these challenges, fewer resources, and less time to get to the solution, it can be extremely easy to lose sight of the grand impact that we as engineers have on the world. And furthermore, these challenges are being compounded by the increasing complexity of today's systems and the rapid pace of technology change. Now, as an example, only a decade ago, a mobile phone testing application would be just about transmitting and receiving signals, and maybe just the keypad as well. Now today, it's a much more comprehensive device capable of serving almost limitless applications defined by software, and therefore requiring a much more robust approach to design and test. So these are the challenges that we face today as engineers. Now, we at NI are absolutely focused as a company and are built to help you make that impact. See, our mission is to equip engineers and scientists with systems that accelerate productivity, innovation, and discovery. So we believe that engineers and scientists are truly the builders of our world, and we believe that we can help overcome any challenge that you may be facing. Now, let's specifically talk about embedded systems design and how NI can actually help you overcome some of these challenges. So when building an embedded system, you will inevitably have to answer the question, should I build it from scratch, or should I buy something off the shelf such as a PLC or a single board computer? Now, each has its own advantages, but in the end of the day, which one is the right one for you? If, for example, you decide to build the device from scratch, you will benefit from the ability to fully customize your hardware and software solution. Now, this will essentially give you maximum flexibility and allow you to add features that you are looking for. But the designs can take a lot of time and resources to complete. Alternatively, if you decide to buy something off the shelf, then you can avoid some of this time and resource investments, but you have that limited functionality. So now let's take a deeper look into each of these options. So even though a custom-built design offers the most flexibility and gives you exactly the feature set that you want, they are very complex. There are multiple aspects that you need to be considering, such as hardware, software, mechanicals, and also life cycle management. For example, you need to figure out what type of computing components are you going to use. It could be either microcontrollers, microprocessors, DSPs, ASICs, or FPGAs. And once you've determined what components you're going to use, you need to develop the software for each one. Furthermore, the software tools used for each are going to be absolutely different. And so you will find yourself creating specialized teams just for each component that you have chosen. Now, it can even get more complicating once you take Moore's law into account. Not only are the components increasing in performance, but the technology is also getting cheaper. This means that in order for your designs to remain up to date, they need to be updated soon after completion. So you'll end up in this constant iteration cycle of upgrading your application. There's also the mechanical design to consider, which involves the design itself, but also the tooling, fabrication, as well as testing. And finally, there's the life cycle management. This is something which most people forget. You have to keep up to date with all the documentation, sustaining certification, and also inventory management. And all this takes up a lot of valuable time and resources. As a result of these challenges and complexities, custom design teams tend to be very large. In addition to the domain experts that have the knowledge of the application in hand, you will require dedicated engineers who specialize in software design, FPGA design, and mechanical design. And depending on the application, you will probably require an analog or digital hardware engineer as well. Now, with a large team like this, it could complicate the whole design process. The engineering team that are actually doing the design work will be further away from the application space, and the product that's being created will be pretty far away from what the domain expert is looking for. And here you can see the true inefficiencies of large embedded system design teams. The size of the average embedded team is approximately 12 people, and the average project takes just over a year to complete. And from the study, we can also see that many teams see the pressures of time to market. Over half of all the projects are either late to market or currently behind schedule. So let me just give you a bit of background as to where this data comes from. Every year, UBM Electronics, the publisher of EE Times, conducts a study of the embedded market, and they ask a wide range of questions from the tools the engineers use to how long they usually spend on a project. So really, this is the reality of an embedded systems design team. And I'm sure by now you're probably convinced that you'd be better off just buying off the shelf. But let's look into that option deeper. So let's look into the decision to buy a commercial off-the-shelf solution, which is also known as COTS. Now this can come in a number of different varieties, like PLCs or single board computers. So there are a number of benefits to going with a COTS solution, which addresses many of the disadvantages of a custom solution, which I talked about before. And these include like faster time to market, as well as lower development and lifecycle management costs, as all the risk is actually being handled by the vendor that creates or produces the hardware. Now, COTS solution also makes it easier to stay up to date with current technology, since you can focus on your domain expertise instead of the custom design. So all this sounds great, doesn't it? But let's look into the downsides. So while a COTS solution has many advantages, there are some drawbacks, and these drawbacks are usually solvable using a custom solution, which I talked about before. Now, this includes limited or sometimes too much functionality. So since you are buying something built by another vendor, you run the risk of not having all the features that you are looking for in your application. On the flip side, you could also be paying extra money for features that you just do not intend of using at all. Now, the other concern is flexibility. You can only get so much flexibility out of a COTS solution, right? So because it's all, usually COTS solutions are designed for a specific purpose. Now, if you need to do anything custom, you may often find yourself like running into roadblocks quickly. Now, many COTS solutions also come with varying levels of performance. It could be either processing power or even the types of I/O or an amount of I/O that you have. So as your application becomes more and more complex, or you have special needs such as customized timing, you might find a COTS solution falling short of your needs. And the same goes for quality and ruggedness. Now, if you have an application or a device that you want to deploy to a harsh environment, ruggedness will be a concern again. Now, all this will potentially make you look back towards a custom solution. So essentially, with a COTS, you get what you get, right? Inevitably, you reach a ceiling of functionality, flexibility, performance, or even ruggedness. So just like custom, COTS also has its disadvantages. So the main question is, why not look for a platform that provides the benefits of both COTS and the flexibility of custom design? So this is exactly the mentality we have here at NI. Why compromise? So as a domain expert, it's important to have access to tools that allow you to realize your goals and dreams. So you should have a design platform where you get the benefits of off-the-shelf technology with the flexibility of custom design so that you can focus on innovation and not the implementation. So the NI approach is to have both. So what sets the National Instruments approach apart from other traditional approaches is that we offer a platform-based approach to embedded systems design. Now, this platform combines a full-featured, highly productive graphical programming environment with customizable off-the-shelf hardware. So when you combine flexible hardware and software into an integrated platform, it allows you as engineers to focus more on solving the challenges that you face within your industry. And at the same time, you worry less on solving the difficulties of communication between hardware components, developing the basic software components, and designing user interfaces from ground up. So having flexible off-the-shelf hardware gives you the ability to innovate with confidence without the expense and complexity of a custom design. In addition to the flexibility of this platform, it also combines the ability to implement custom algorithms such as high-speed control and processing and world-class analog and digital I/O into a single system using all off-the-shelf products. Now finally, this platform is also built and tested with the highest quality, which allows you to deploy reliable systems that last even in the harshest of environments. So essentially, National Instruments changes the game through a platform-based approach. Now this is basically a combination of three elements: high-level software, flexible hardware, and integrated hardware-software platform. And this gives the benefits of COTS with the flexibility of custom design. So as I mentioned in the last slide, the key to getting the flexibility of custom design with off-the-shelf technology is through a platform-based approach. Now at NI, we call this approach graphical system design. So graphical system design is about using intuitive graphical software, which is a high-level abstraction, to define hardware functionality. So all this translation is made possible by the LabVIEW platform, housing multiple ways of describing systems that can automatically deploy to multiple processing and I/O form factors. So this accelerates the development of any system that needs measurement and control in test, monitoring, embedded, or any combination of these applications. So this approach gives you reuse of a software-centered platform that has the ability to target multiple hardware form factors that shares a reconfigurable architecture. So essentially, when you develop for one application area, you can easily morph from that application area to another application area because you're still using the same underlying software platform, which is LabVIEW. Now what's great is that once you've applied the platform to a single problem, you can use it to scale to multiple problems, having the ability to add future requirements and technologies. So LabVIEW is really the key to all this, or pretty much the heart to all this. It's the ultimate system design software to integrate the I/O that you need to create your systems. So here's some insight to the heart of graphical system design, the LabVIEW platform. So for over 26 years now, LabVIEW has really made engineers more productive by ensuring that they can take full advantage of hardware products. And also they are able to use them with all of the analysis and UI capabilities necessary for any measurement or control system. So LabVIEW allows users to develop their own application IP, build their user interface, and manage all hardware from a single location. So essentially, LabVIEW increases productivity by abstracting the low-level complexity. So integrating all the technology engineers and scientists need into a single unified development environment. So, this is basically unlike any other text-based alternative out there. So every year, each new version of LabVIEW is designed with features to further enhance and accelerate productivity through the input of our users out there. So the second component of the graphical system design approach is flexible commercial off-the-shelf technology. NI's approach to this flexible hardware is to combine a user-programmable FPGA, which is known as a field programmable gate array, a host processor, and high-quality modular I/O together into a single system. So I guess the first question is, what is an FPGA? Well, for those of you that are not familiar with FPGAs, an FPGA is a device that contains a matrix of reconfigurable gate array logic circuitry. So when an FPGA is configured, it's quite different from programming a processor. So the internal circuitry is connected through a software application, essentially defined through software. So unlike any processors, FPGAs use dedicated hardware for processing logic and do not have an operating system. So what that means is that FPGAs are truly parallel in nature. So different processing operations do not have to compete for the same resources. So as a result, the performance of one part of the application does not affect any additional processing or logic that's added. So essentially you can have multiple control loops that can run independently on a single FPGA device at different rates. So what's great about these FPGAs? Well, the fact that it's reconfigurable in nature, an FPGA system can be even reconfigured after the control system is deployed to the field. Now, this is actually a big advantage because when you change your IP requirements or requirements of the hardware that's deployed, it's very simple to be able to constantly update it down the road or for future proofing. So FPGA devices actually deliver the performance and reliability of dedicated hardware circuitry. A single FPGA can replace thousands of discrete components. So instead of having all these multiple components, you can just add the logic of these components into a single integrated circuit chip. And now, a big changer in FPGA world right now, over the past few years basically, is the incorporation of hardcore DSP slices. Now these are like having mini DSPs inside the FPGA fabric that can communicate with the outside world with very low latency. So DSP slices are ideal for implementing IP for complex mathematics like filter designs and doing various types of quick math to do online processing. So the FPGA is the core of this approach as it gives the user a lot of power and flexibility. Now the flexibility comes from the user being able to define how the hardware operates. So basically the ability to implement custom IP directly on the FPGA, such as high-speed closed-loop control algorithms, custom timing and triggering, or even inline signal processing is extremely powerful. So however, only having an FPGA is not enough. While it gives your application a lot of flexibility, you still need to connect to the outside world. So an application could have a number of I/O requirements. So having quality modular I/O that includes all the signal processing built in is required. So this allows you to connect your hardware to any sensor on any bus. And then finally, the hardware will need to include some sort of host processing, right? So this will allow you to run all of your application software as well as your user interface. So you generally have a choice of maybe a real-time operating system or a Windows-based operating system or maybe even a Linux operating system. So a real-time operating system usually will offer deterministic operation for like time-critical applications, where a Windows or Linux-based operating system offers the maximum flexibility because you have all the driver access. In addition to all this, the host processor is ideal because it also offers the networking stack, which allows you to connect to additional systems. Now still, while having all these components are great and offers a lot of flexibility, they all still need to be programmed. In addition to programming the individual components, the interconnects need to be programmed as well. So using LabVIEW gives you the benefit of programming all of them from the same environment, including the interconnections between the components. So this integration of highly productive software and flexible hardware is what we call the LabVIEW Rio architecture. So this architecture is manifested in several different ways. The first of which is our flagship embedded control and monitoring platform named Compact Rio. Now this platform is built upon the LabVIEW Rio architecture, which consists of an embedded controller for communication and processing, a reconfigurable chassis housing the user programmable FPGA, and hot swappable I/O modules that allow you to connect to any sensor on any bus. Now, the Compact Rio system is designed for extreme ruggedness, reliability, and I/O flexibility. With 50G shock ratings and a wide temperature rating from -40 to 70 degrees Celsius on some models, the Compact Rio system is ideal for automotive, industrial automation, and even advanced control applications. Now, Compact Rios are also available with conformal coating options for an even higher level of ruggedness. It also offers high levels of processing performance, with up to about 1.33 GHz dual-core Intel i7 processor at low power consumption levels. So these flexible systems offer the processing power you need for advanced control applications, high-speed data transfer and logging, and processing intensive applications such as rapid control prototyping and advanced motion Finally, LabVIEW allows you to target the compact RIO directly from the project and allows you to program the embedded processor, FPGA, and interface with the I/O all from the same environment. So the compact RIO leverages the LabVIEW RIO architecture and offers high level of ruggedness and performance. Now, one element of the compact RIO platform that is worth taking a deeper dive into is the C-Series I/O modules. So these are hot swappable C-Series I/O modules that provide direct access, or at least direct hardware access, to the input and output circuitry of each I/O module. So essentially, giving access to the I/O from the FPGA for inline signal processing or analysis. So each I/O module contains built-in signal conditioning, and they all have either screw terminal, BNC, or D-sub connectors. So currently, there are more than 100 C-Series modules for different measurement types, including thermocouple, voltage, RTDs, current, resistance, strain, digital, either TTL or other types, accelerometer, microphones, and so on. There are also specialty modules that allow you to integrate the compact RIO into complete systems. So these modules include, but are not limited to, motion control, industrial vision, industrial bus communications, and many other more specialty modules out there. And it's constantly growing based on customer and user input. So in addition to this wealth of modules from NI, there are also a number of modules that are developed by third-party vendors for applications and industry-specific needs out there. So C-Series modules are actually an open platform. So if you need to develop a specific C-Series module, you can actually build your own to meet your own specific needs with our module development kit. Now, if you do find that you need a more flexible approach when it comes to mechanicals or I/O connectivity, you can also leverage the NI single board RIO. Now, this is a board-only form factor of a compact RIO, essentially, but it gives you the flexibility to integrate your own mechanicals and I/O connectivity. And then all this while even allowing you to leverage the same architecture for deployment. So if you need something that has a customizability for mechanicals or I/O flexibility, you can choose the NI single board RIO. So alternatively, if you need more performance than the compact RIO, then you may consider leveraging PC or PXI based systems. So the R series and Flex RIO targets offer the fastest I/O rates as well as the largest FPGAs. They are ideal for applications that require custom digital protocols, complex timing and triggering, control at megahertz rates, as well as precise timing and high reliability. So by using the NI-R series or NI Flex RIO, you can still leverage the same architecture while taking advantage of performance benefits of the PC and PXI technology. So a PXI is a rugged PC-based platform for measurement and automation systems. Now PXIs are both a high-performance and low-cost development platform. So by leveraging PXI, you can essentially combine the LabVIEW RIO architecture or the hardware with a wide range of modular instruments. Now, the instruments that we talk about basically deliver flexibility for software-defined solutions for complex measurements and challenges from DC to microwave frequencies. So if you need more performance or want to leverage PC or PXI technology, you might want to look into the R series or Flex RIO systems. So as you can see, there are a wide array of options for you to choose the LabVIEW RIO hardware target that is right for your specific application. Now, all of these hardware targets leverage the LabVIEW RIO architecture. The LabVIEW RIO architecture breaks into different hardware products, which basically fall into three main categories. That's the compact RIO and SB RIO, and you can have optional expansion I/O for your distributed applications. And the last category will be high performance. Now, all of these products come in many different variants, which range in performance, including I/O, CPU speed, memory, and FPGA size. But don't forget, it's not just hardware. Remember, it's a platform-based approach, which means the software and hardware are integrated together. Instead of using separate different design tools to program all the different components, you use a single IDE. So IDE is known as Integrated Development Environment, which creates the same experience throughout your whole process. Now, by having software that inherently understands the hardware, it allows you to increase your productivity by extracting fundamental components such as inter-element communication and different I/O types. And furthermore, tasks such as debugging, timing, and deployment become streamlined and a lot more straightforward. So this platform-based approach allows you to create a lean embedded systems design team and allows domain experts to focus on innovation and not the specific implementation. So we have seen how leveraging a platform-based approach provides more productivity and flexibility over traditional approaches. The other benefit of the platform-based approach from NI is that it's not just the tools, but it's an entire solution for success. So the graphical system design is not only a platform that you can leverage for your design, but it's an entire solution altogether. Now you may remember this slide from earlier as I presented it before. If you remember, basically using a traditional approach, you inevitably encounter delays and have long completion times. Well, what's interesting is that UBM conducted the same study on NI customers, asking the same exact questions as this particular study here. And as you can see, the results were astounding. Not only are NI customers completing more projects on time, but they are doing it in less time with fewer resources than those who are following the traditional approaches. Now, this is really made possible by using the platform-based approach. Now, by combining the best of build and the best of buy, as well as leveraging integrated high-level software with flexible off-the-shelf hardware, you get the opportunity to focus on innovation and not your implementation. So graphical system design and the LabVIEW architecture provides quality products and the confidence to innovate while getting your project done in less time. So on your next embedded systems design, as you come to the inevitable question of build or to buy, you should ask yourself, why should I continue to compromise? Why can't I just have the best of both worlds? Well, now you can by leveraging graphical system design and the LabVIEW architecture. So, to further ensure your success and satisfaction, the NI Global team of technical sales consultants can work with you to develop the right solutions for your application needs. So the NI technology specialists offer expert advice on the latest industry trends and can simply provide system development advice by personally guiding you through the NI product line, performing on-site demonstrations, and assisting with reference and application architectures. Furthermore, we also offer local technical support worldwide through our application engineering department. Now, if you need technical assistance with your hardware, software, or application, our engineers are in your local area and are ready to help. So we also have a whole ecosystem of NI Alliance partners. Now, there's hundreds and hundreds of partners that's available throughout the whole world and even in your local area. So the National Instruments Alliance Partner Program is a worldwide network of more than 800 consultants, system integrators, developers, channel partners, and industry experts who partner with NI to provide complete, high-quality solutions to customers. So whether you're looking for assistance in completing a small integration project or want to find a turnkey solution, National Instruments Alliance Partners has the resources and the know-how to provide what you need in every region and every industry. And to give you more confidence, we believe that the best way to serve our customers is to ensure a successful, stable company which our customers can rely on for products that will be of consistent quality over time, and also provide customers with service for the decades that our products will be used for. So NI has a strong track record of sustainable growth and profitability because we are managed for the long term. Now, this whole sustainable ethic is reflected in our growth, our breadth, and our diversity of industries that we cater to. We also reflect it in our culture of being a consistently great place to work for throughout all our offices worldwide. Now, to end off this whole webcast, I'd like to state that you need to look into a platform-based approach to embedded systems design. So that's all I have for you today. Do you have any questions?